Hello students, welcome to Target IES. In this video I am going to continue with module number 14. Okay, in this module I am not teaching anything new, but I am just continuing the part of module number 13. So please make sure that you are perfect in module number 13 before watching this module number 14. Okay, so basically in the last module, which was module number 13, we have seen how to find the displacement, right? So what was the formula we used to use? Sigma pkl by ae, right? Using this formula I used to get displacement when the loads are applied. In place of load, if there was say temperature rise, then what was the formula we used to use? Temperature rise or fall, we used to use K into delta, right? So same question, let us go to the advanced part. In this question I want to find what is relative displacement of the joints. Okay, previously whenever I want displacement of a joint, okay, for example if I want displacement of joint of the member E, first I used to find what are the P in all the members. Okay, then I used to find what is K value in all the members by assuming there is a unit load acting in the direction of the displacement we needed, right? If we need horizontal displacement, I used to apply unit load in horizontal direction. If I need vertical displacement, I used to apply vertical load of 1 unit in vertical direction. Okay, but now he is asking relative displacement of a joint. He is asking, for example, if you want relative displacement between two joints B and D, then you have to apply the unit load in between these two joints. Okay, if you want relative displacement, what you have to do? You have to apply the same unit load in between these two joints. That's it, rest is same as it is. Okay, now let us solve this question. Here we have to find relative displacement because of the temperature rise or fall. See, if we have to find the relative displacement because of the some load acting, for example if there was some load acting 10 kilonewton or something, then what we have to do? We have to use formula sigma pkl by ae. First find p values because of this 10 kilonewton, then remove this 10 kilonewton, apply this 1 unit load, and then find K values in all the members because of this 1 unit loads and use formula pkl by ae. But now in this question he is asking to find the relative displacement when these members of the trusses are subjected to temperature change. When there is temperature change, what is the formula? K into delta. Okay, so find the delta and find the delta in all the members. What is the delta formula? L alpha t. Our elongation was L alpha t. Find that in all the members and then find K values because of these unit loads in all the members and multiply it. Okay, then do summation of it, you will be getting your displacement. You will be getting your relative displacement. That's it. Now let us solve this problem very quickly. See, the problem is already given in the hard copy, right? You can just go through it, but I am going to teach you this in detail. Please don't skip and watch it carefully. I don't want you to make any mistakes. Okay, so what is the angle? First of all, it is making, can you tell me what is the angle here? For example, if I take, I have to apply the unit load like this, right? It has to be like this. It has to pass through these two joints. Okay, now can you tell me what is the angle between these unit loads? Okay, here it is 3 meters, here it is 4 meters. It is something like this, right? It is something like this, 3 meter, 4 meter. So what should be the hypotenuse? Hypotenuse is 5 meter. Then what is the theta? Cos theta will be 3 by 5 and sin theta will be 4 by 5. Agree? Sin theta is opposite by hypotenuse and cos theta is adjacent by hypotenuse. So you will be getting 3 by 5 and 4 by 5. Okay, so first let us find delta values, the elongation in the member. He said only the two members CD and DE are subjected to temperature fall of 40 degrees centigrade. Okay, so only two members are subjected to temperature change and remaining members there is no temperature change. The delta for rest of members is 0. Okay, so what is delta CD? L alpha t. What was CD length? CD length is 5 meter because this is 4, this is 3, hypotenuse is 5. Okay, 5 into alpha value it is given 12 into 10 to the power of minus 6, t is 40 degrees, right? So what you will be getting? 2.4 into 10 to the power of minus 3. As the temperature is fall, whenever there is a fall, what should be the delta value? Positive or negative? Negative. Or you can directly take here as minus 40. The temperature change is minus 40. Then you will be getting negative value. Up to you. Both ways you can use, but your answer should be negative when there is a temperature fall, and your answer should be positive when there is a temperature rise. Okay, now delta DE is this member, right? So delta D again L alpha T, length is 3 meters. So alpha value is 12 into 10 to the power of minus 6, and temperature change is minus 40. You will be getting minus 1.44 into 10 to the power of minus 3 meters. And what is the elongation in the rest of the members? It is 0. So half of the question is done. So what we have to find? Summation of K into delta, right? So delta values we already find. Let us find K values. So what we have to do? We have to apply unit load along BE. Okay, so we already have just seen what is this theta. So let us find out using any method of joint, method of section, it is fine. You have to find K values in the members. See, you need not find K values in all the members. Okay, you need not find K values in this member, this member, this member, this member, this member, this member, and this member. Okay, you need not find K values in all the members, because we know in most of the members my delta value is 0. My delta value is not 0 only in DE and CD. If I find K values for these two things, it is enough, right? Because delta value is 0 here, delta value is 0 here. So whatever K value you get, even you get K value as root 2, root 3, it doesn't matter. Anything into 0 will be 0. So don't waste your time. So let us calculate only two things here, KDE and KCD. More than enough. And you will be getting your 2 marks. Fine. So how to get KDE, KCD? So you have to use method of joints or method of sections. Whatever method you are using, what was our first step? First step was to find support reactions. To find support reactions, what you can do? You can use 3 equations: sigma x is equals to 0, sigma y is equals to 0, sigma m is equals to 0. Okay, if I use sigma y is equals to 0, now let us see this force. It is 1, right? So horizontal component is 1 cos theta, vertical component is 1 sin theta. Similarly, the horizontal component 1 cos theta, and vertical component 1 sin theta. Agreed? So what is my sigma y is equals to 0? It will be RA, my support reaction RA and RC, right? And two external load 1. So let us see what is my sigma y. So I will be getting RA plus RC plus 1 sin theta minus 1 sin theta is equals to 0. See, this is going upwards, 1 sin theta plus, and this is going downwards, 1 sin theta minus. So my RA plus RC value is equals to 0. So that is my equation number 1. Okay, now I can apply moment. I can apply moment at this joint or this joint. Let us take MA is equals to 0. Okay, I am taking moment at this point is equals to 0. Okay, now see, let me change the color of the pen so that, just give me a second, let me change it. Let us select some purple. Okay, now see this component 1 sin theta, it is passing through A, so there won't be any moment because of this 1 sin theta. Perpendicular distance is 0. Again 1 cos theta component from this member B, it is passing through A again, so again the moment is 0. It is not causing moment, and this is not causing moment. So what is causing moment? 1 cos theta component, because it has some perpendicular distance of 4 units, right? It is causing moment. And obviously 1 sin theta, it has a perpendicular distance, of 3 meters, right? So it is also causing moment. And obviously RC, it has 3 meters and 3 meters, 6 meter distance, right? So it is also contributing to moment. So let us write the moment equation. So if I am taking a joint A, my moment equation will be RC into 6. Okay, RC into 6. I am taking anti-clockwise positive. It is up to you. If you are taking anti-clockwise positive, clockwise will be negative. If you are taking clockwise positive, anti-clockwise will be negative. Up to you. Okay, so 1 sin theta into 3. So this component 1 sin theta, and perpendicular distance is 3 units. So just multiply 1 sin theta into 3 minus, see, now this component, it is moving in a clockwise direction with respect to point A, right? It is moving in clockwise direction, so I am taking it as negative. It is up to you. If you have taken this clockwise as positive, obviously these two will have been negative, so you will be getting the same answer. Okay, it doesn't matter if you are taking positive, negative for clockwise or anti-clockwise. So your RC value is 12 by 5 minus 12 by 5 is equals to 0, because what is your sin theta value? Sin theta value you have calculated, right? 4 by 5. Cos theta value was 3 by 5. Okay, 4 by 5, 4 into 3, 12 by 5. Again here also 4 into 3, 12 by 5. So if you minus it, you will be getting 0. Done. So it was Just a second. As you got your RC value as 0, what should be your RA value? Just substitute RC in equation number 1 which you have got. So your RA value is also 0 because RA plus RC was equal to 0. RC is 0. Therefore my RA value is 0. Simple. So 99% problem is already finished. 99% problem is already finished. Obviously you can find HA also using sigma x is equals to 0 or sigma h is equals to 0, up to you. Okay, so if you use sigma h is equals to 0, what you have to get? What are the forces? See, at the joint B, at the joint C, we have a roller support. So this component is 0. At the roller support, you don't have any horizontal component. We have horizontal component only at A, right? So here I got 1 cos theta horizontal component because of the external load, and here also I got 1 cos theta horizontal component because of the external load. Both are in opposite direction, so both of these cancel, right? HA plus 1 cos theta minus 1 cos theta is equals to 0. So if you equate, you will be getting 1 cos theta get cancelled, and you will be getting HA is equals to 0. So HA component is also 0. If you want, you can find it, or no need also, because for this question it is no need. For some other questions it might be needed, so I have calculated. Okay, so I got all the external reactions also. So let me erase this. Now we have completed the problem already. We just have to do a final calculation and it is done. So what was our RC value? Our RC value was 0, right? So our RC value was 0. Now see these two members. It is like two members meeting and no external load, right, at this joint. So both are carrying zero force. Both are the 0 force members. So my KDC is nothing but 0, or KCD is nothing but 0. Okay. Now let us find what is the force in the member KDE, because we want only two K forces, KDE and KDC. Okay. So use sigma h is equals to 0 at this joint E. Okay. If I am using sigma h is equals to 0 at joint E, what I have to get? 1 cos theta, right? 1 cos theta. I am assuming this side as compression. Okay, KE as compression, because it is a tensile force, right? If you are taking component, it will also have bit tension. So to be equal, it has to be to get 0, to get sigma h is equal to 0. Obviously, it has to be a compressive force, right? So KDE is equals to minus 1 cos theta. 1 cos theta was 3 by 5 compression. If 3 by 5 compression means minus 3 by 5. Always remember, compression means you have to write minus value. If tensile, you can write 3.5. As it is compression, you have to write minus 3.5. So what is your answer? Your answer delta was sigma k into elongation delta, right? So k value for CD into elongation for CD plus k value for DE into elongation for DE. So what was k value for CD? It was 0, right? So it is 0. So this term is gone. It is 0. Now KDE plus delta DE. Delta DE value, you have calculated. You have calculated in the first step itself. Delta DE value, it was minus 1.44 into 10 to the power of minus 3. What was KDE value? KDE value was minus 3 by 5. Just multiply these two things. Minus 3 by 5 into minus 1.44 into 10 to the power of minus 3. See, I have clearly given the step. Don't worry, you need not write anything. So just follow this step, you will be getting your answer. Minus 3 by 5 into minus 1.44 into 10 to the power of minus 3 is nothing but 8.64 into 10 to the power of minus 4 meter, and you will be getting your 2 marks in GATE and ES. Okay, so I hope you are perfect in this thing. Okay, please practice the above problem one or twice, because there are so many examinations in which he has asked what is the relative displacement. It is an important question. Okay, so now coming to the next part. This note is also super important. This note is super important for entire structural analysis. This note will be repeated at least thrice. Okay, this is the first time I am telling this, but it will be repeated another 2 times. Okay, so what is this note? First read, I will then explain. In any statically determinate structure, due to temperature change or due to sinking or due to yielding of supports, stresses are developed anywhere in the structure because rigid body rotation or rigid body translation will occur. Okay, what he is trying to tell is, if we have a statically determinate structure, because of the temperature change or because of the sinking or because of the yielding, there won't be any stresses developed in the body. If it is an indeterminate structure, if it is indeterminate structure, 100% there will be stresses develop. Stresses develop because of temperature change, okay, because of temperature change, or because of sinking, or because of yielding, okay. But if it is determinate structure, then these three will be absent. Stresses due to temperature rise, sinking and yielding will be absent, okay. Because if you are taking a statically determinate structure, let us take a cantilever beam like this, okay. You apply the temperature, obviously it will get elongated, so there is no reaction, it is free to expand, right? So no stresses are developed in this body, it is just expanding and there is no stresses being developed. But if I have a cantilever beam, now fix it, okay, I am making a fixed beam, so what will happen? As it is trying to move in this direction, as my cantilever beam is trying to move in this direction, I have a fixed support which is not allowing this beam to freely expand, so obviously there will be stresses developed. It is trying to expand and this is not allowing to expand, so what will happen? The stresses will generate. But if you don't have this, you have only cantilever beam, something like this, it is free to expand. As the temperature is rising, this will go on expanding without any rising stresses. Similar to the yielding and the sinking, okay. If you have a determinate structure like this, so one side we have a pin support and other side we have a roller support, so it is a determinate structure, right? So if I have a determinate structure, sinking, then what will happen? We have a rigid body translation. For example, let me say this is pin and this I have a roller support, okay. So if this support is sinking, you can see it is a perfectly straight line, right? Rigid body rotation is occurring. If it was fixed, if I have to bend it, okay, if it was fixed and it was pinned, if I want to try to bend it, what will happen? Obviously you can't bend it with these, right? Then you will be getting a non-linear structure, at the same time stresses will develop. But here it is a pin joint, here it is also pin joint, but roller support extra. Now when it is sinking, there won't be any reaction because of the sinking developed, and it will be a perfectly rigid body rotation and no stresses will be developed because of the sinking in a determinate structure, similar to that of the yielding, okay. Even if the support has been yielded, it was in this position, now it has moved to some other position, the support has been yielded because of application of load, even then there is no stresses developed in a determinate structure, okay. So what is the difference between sinking and yielding? Many people don't understand, they break their heads understanding this. It is so simple. If you don't know, you will always have this confusion and fear regarding the yielding, right? Sinking is nothing but vertical movement, whereas yielding is horizontal movement, that's it, okay. If your body is falling freely like this, it is falling freely, or it doesn't matter. If your structure is falling in a vertical direction, it has some vertical movement, it is called as sinking, right? Sinking of the support. At the same time, if it is moving horizontally, then we will be calling it as yielding of the support, that's it, okay. Simple, right? I hope this note is clear. Make give this note 5 star, because he can ask you in an objective purpose. If you are preparing for any state PSC, or now the railway exam is coming, right? Railway JE, this is the hard favorite bit. For sure there would be one question in one of the exam which you are going to appear in this particular year, okay. Now let us go to the next question. This question is also very important and possibly the last kind of the problem which you are going to solve, okay. So here we are analyzing free body rotation of any member. See, the displacements are of two types. I have clearly explained you. The displacement was linear displacement, deflection delta, or angular displacement theta, okay. Now consider a truss like this, okay. If we want the deflection, what we used to do? We used to apply unit load at the joint whichever you want deflection, right? For example, first what you have to do to find deflection, we, due to this load W, applied load W, we have to find the forces P1, P2, P3, P4, so on, okay. We have to find all the forces in the member, and then we have to remove this load W and place unit load in the direction of the deflection which you want at the joint wherever you want to find the deflection, and again find the values K1, K2, K3, K4, so on, right? So what you have to do finally, you have to summate both the things, and your formula was summation of pkl by ae, and you will be getting your deflection. Very similar to this, very similar to this. If you want unit rotation of any member, for example, if you want unit rotation of this member ef, okay, if you want unit rotation of this member ef, then you have to apply unit couple in place of unit load for deflection. Okay, this was unit load, right? For rotation, what you have to do, you have to apply unit couple. So I hope what you know what is couple, right? You might have studied in your school as well as engineering mechanics. Even you don't know, don't worry, I will explain you. So couple is nothing but two unlike parallel forces of equal magnitude. Okay, first of all, if two forces are moving in the same direction, okay, they will be called as parallel forces. They can move in the same direction or opposite direction. Okay, so if these two forces are moving in the same direction and have same constant distance between them, we will be calling it as like parallel forces. If two forces maintaining constant distance but are of opposite signs, we will be calling it as unlike parallel forces. Couple is nothing but unlike parallel forces of equal magnitude. If it is f, this is also f. So what is the couple? It produces moment, right? This couple produces moment. See, it is producing a clockwise moment, and whatever point you take in between these two forces, your moment will be nothing but force into distance between these two forces. Okay, for example, if I am taking the midpoint is a by 2 on this side, a by 2 on this side. So what should be the moment due to this force, this first force, the moment due to the first force on the midpoint, force into perpendicular distance, which is f into a by 2. Now due to the second force, it is also moving in clockwise. This was moving in clockwise, this was moving in clockwise. So plus f into what is the perpendicular distance again? A by 2. So what is your answer? F into a by 2 plus a by 2, which is nothing but f into a. So if there is a couple, it produces a moment, a constant moment between these 2 points on anywhere. Okay, if you are taking even a by 4 point, okay, if you are taking the quarter point, this is a by 4 distance and remaining is 3a by 4, right? 3a by 4. Okay, so f into a by 4 plus 3a by 4, that will be the moment. So again f into a. Okay, so this is the importance of couple. If there are two unlike parallel forces of equal magnitude, okay, then there will be a constant moment generated in between these two forces. Okay, let me erase this. So what we have to do, we have to apply unit couple. What is unit couple? Now you understood what is couple, you understood what is couple, but what is this unit couple? Unit couple is nothing but a couple which is generating unit moment. Okay, so what was the moment between these two forces? If it is f and if it is f and the distance is a, okay, so what was the moment being generated? F into a. Okay, but I want unit couple, means moment is 1. So what should be my f value? F value is nothing but 1 by a. Okay, if I have a member on which I am applying 1 by a load on both the sides which are unlike parallel, okay, then I will be calling it as unit couple. Okay, so I hope it is clear what you have to do. If you want the rotation of the member E, just give me a second, let me erase this. Yeah, if you want unit rotation of this member EF, what you have to do, you have to apply unit couple, that is 1 by, if this distance is a, then 1 by a and 1 by a. Okay, and find k values for all the members simultaneously. Okay, just find k values in all the members because of this loading condition, 1 by a at this joint and 1 by a at this joint. So you will be getting your k values, and again do sigma pkl by a, sigma pkl by a, you will be getting your rotation value. Okay, so just give me a second, I want to explain you one more thing. See, in the hard copy of the notes, instead of finding the rotation for the member FE, I have found the rotation for the member GF. Okay, the same concept. If the distance is a, you have to apply unit couple 1 by a and 1 by a and find k values, and then finally do sigma pkl by ae, and you will be getting your answer. Simple enough, no issues. But I want to tell you one more hack. Okay, what am I teaching you? I am teaching you hack. So basically, rotation of the member means, for example, if I have a member GF like this, right, it is perfectly straight. It is perfectly straight first of all. Now the member has been rotated by some angle theta. Okay, so whatever the angle theta GF, it will be the same, right? Now this was your initial position. Now it got tilted. Okay, this angle GF will be same, right? Here also it will be making angle GF only, right? Angle theta GF. Okay, what should be the this tan theta GF value? If it has been rotated, that means this body has been lifted up, there has been some deflection. This F point, it has gone down, so there has been some deflection in opposite angle, right? So this is my delta G and this is my delta F, the deflection at the point G and deflection at point F. Okay, so what is my theta GF? See, this is making a triangle like this. Okay, this length is nothing but theta G plus, sorry, delta G plus delta F, right? So delta G plus delta F. And what is the distance? Distance is A, right? So what is my tan theta GF? Tan theta GF value is nothing but delta G plus delta F by A. So instead of doing sigma pKl by AE, okay, you can also do this. You can find what is the deflection at the point G and point F individually. Okay, you can find what is the deflection at point G and point F individually, and then you can apply delta G plus delta F by A. Both ways you can do. Okay, this method is simple if you are finding for a new member, but if you already have values of delta G and delta F, don't go for this method. Just you have to do, if you know the displacements of two joints and he's asking the rotation of this member, then what you have to do, you just have to do delta G plus delta F divided by A. Okay, don't get confused. In objective purpose for GATE and ESC, you don't have time to find the deflection of point G and point F and then doing by A, right? In some exams, what they do is they directly give what is the deflection at G and F, and he asks you to find rotation. People get so confused. They think they can't solve this question in 1 minute, but actually you can solve it in 30 seconds. All what you have to do, you have to add the deflection at this joint and this joint and divide it by the distance. You will be getting your tan theta. Tan theta will be equals to your theta. Okay, why? See, this member is not rotating by some angle of 45 degree or 30 degree. Okay, if it rotates so much, it will be called as fade. Okay, it will be rotating just like 1 degree or even less than 1 degree. Okay, so the tan theta G value is so less that it will be equivalent to your theta GF. Okay, no issues, right? So this is the hack which I want to teach you. So first read the question carefully and then you decide whichever method you want to solve. Okay, so in this question he is asking us to find what is the rotation of the member AB, right? For a truss shown in the figure, rotation of the member AB is, where is our AB? This is our AB. Okay, so very good thing about this question is, this is a very simple question. See, what is our theta AB? Sigma pKl by AE, where K is the forces in all the members because of the unit couple applied on this member. So you have to apply unit couple, right? Something like this. If this distance is given as 1 by 3000 mm, right? 3000 mm. So what is your force? You have to apply 1 by 3000, right? 1 by A was 3000, so 1 by 3000, and you can find K values in all the members and do sigma pKl by AE. But one good thing in this question is, see, if you see properly, K into PL by AE, where PL by AE was our elongation, right? Here elongation is directly given, minus 2 mm plus 5 mm plus 4 mm minus 2 mm. Okay, so this question is very important. Okay, for saving time, you need not calculate PKL by AE in examinations like GATE and ESC. In some questions, to make it simple for students, he directly give you delta values. Okay, so what you have to do, you just have to do sigma K into delta. You will be getting your answer. Okay, now let us solve this question. Just give me a second, let me erase this. So what is the first step you have to do? Whether you are using method of joints or method of sections, first step is to find your support reactions, or you can eliminate zero force members. See, the first step was to find the support reactions, right? Or you can find zero force members and then find the support reactions. It is up to you. If you want support reactions, if you want to find support reactions, okay, if you have experience, okay, if you solve like 50 problems, then you can directly find zero force members in the single shot. Okay, no need to find for support reactions. But as you are still learning phase, go step by step. First do the support reactions. See, at this level I have some experience in solving the trusses, right? So I can directly identify what are the zero force reaction. How I will identify? See, at the joint A, two members are meeting, two forces are collinear and third force is making some angle theta, so therefore this is zero force member. Zero. Clear? Now see the joint C, again two forces are meeting and third force is making some an angle and there is no external load, therefore this is also zero force member. Okay, I need not find support reactions, I can directly find zero force members. Okay, so obviously these two forces are collinear, so this one should also be making 1 by 3000, right? These two forces are collinear, so obviously it should be making how much force? 1 by 3000, right? Okay, now see this member, this is a zero force member, so I am removing it, no need of it. Okay, two forces are meeting and the third force is making some an angle. Okay, this is eradicated, I can remove this member because it is zero force member, and again no load is acting, so therefore two forces are collinear and third force is making some angle, so obviously this is also a zero force member. Okay, so I already found what are the zero force member, and this load has been carried to 1 by 3000 has been carried to here, this member, so this is 1 by 3000 and this is carried to this force, so this force is again it is 1 by 3000. Then similar to that, this was 1 by 3000, so again the support reaction is 1 by 3000. Okay, I can solve like this also, where I got k values very fast because I know the k values now. The k value in this member is 1 by 3000, k value in this member is 0 0 0, again in this member is 1000, 1 by 3000. Okay, so this is a simple step. Or else what you can do, you can find the support reactions. How to find the support reactions? Support reactions, you can take moment equation, sigma x is equals to 0 or sigma y is equals to 0. Just take the moment equations. Okay, just take moment equations. So you take moment equation at any joint C. Okay, what you will be getting? This force is passing through the joint C, so zero moment. This force is passing through the joint, so zero moment. So your reaction, whatever RD is there, RD into distance is 3000 mm, right? Into 3000 mm should be equals to RA into 3000 mm. So your RD value is equals to RA. Okay, so RD was this direction and I am considering RD as this direction, so RD value is 1 by 3000 again. Similarly, you can take moment at point D and find out for your RC. Okay, you will be getting your RC again as 1 by 3000. So once you find support reactions, obviously you can use equilibrium equations at the joints and find out what are your K values, up to you. So you can just identify zero force members like me and write out the K values directly, or you can find the support reactions first and then use sigma x, sigma y, sigma n is equals to 0 equations and find K values, up to you. Okay, you will be getting the right answer. So once I know the K values, what I have to do? I have to do my theta AB is equals to summation of K into delta. So this is a zero force member, zero force member, zero force member, so only force members are 1 by 3000 and 1 by 3000, DA and CB, remaining are 0, right? So let us write only for these two members, AD and CB. Okay, so 1 by 3000, because you can see it is going, AD is a tensile force, it is going away, so 1 by 3000 positive. You can see CB, it is coming towards the joint, so 1 by 3000 negative. Okay, compressive forces are negative, right? So what was the elongation in AD? The elongation in AD was minus 2 mm and elongation in CB was plus 4 mm. So just multiply it with minus 2 and plus 4, you will be getting minus 2 by 3000 minus 4 by 3000. Okay, so just add both, sigma K delta, that will be your answer. So your theta is 2 into or 6 by 3000. Okay, 6 by 3000. What are the units? Units will be radians. Units are radians. Always remember the units is radians. So 6 by 3000 is nothing but 2 into 10 to the power of minus 3 radians. So this is your theta AB value. Okay, or you can use some common sense while solving this problem. What is that common sense? Let me show in the question itself. So this was your member AB initially, right? This was your member AB initially. So what happened this side it got shorted, right? Your AD got shorted. So your A point has been moved to the new location. So what is the distance it has moved? It has moved by 2 mm. Okay. Now B point. This CD has elongated, right? So what is the new position of B point? B point has moved by 4 mm. Agreed? So this is your rotation, right? How to get your rotation? Theta AB is nothing but your delta A plus delta B divided by distance. Delta A plus delta B divided by distance. So what was your delta A plus delta B? 2 plus 4, 6 mm divided by distance 3000. So your answer is 2 into 10 to the power of minus 3 radians. You can solve in 10 seconds. Okay, you can do step by step and waste 2 minutes, or you can directly use your common sense and get your answer. Okay, first of all, whenever the question is asked, think twice for 10 seconds. Okay, think twice for 10 seconds and select the best method possible. Okay, and save your time in examination. See, your ESE is all about saving your time. There will be so many questions, right? If you are taking the theory part, you have to answer like 150 questions. In 3 hours you have to solve 150 questions, and it is heck of time. Okay, you cannot solve all the questions. Okay, if you are solving the lengthy questions first, you are simply losing your marks by missing the simple questions. Okay, if you find some question lengthy, skip it for that time. Go for smaller questions first. Once you are done with smaller questions, then start with longer questions. In longer questions also, first see if there is any logic. Using that logic you can solve the question. Okay, if you find any such logics like this simple logic which you can analyze the problem, then go for that step. Only if there is no other way possible, only then go for the long methods. Okay, so this is what I want to teach for this module. In the next module I will be teaching some more problems, 2-3 problems, and we will also solve lot of ESC previous questions, ESC and GATE previous questions. Okay, have a nice day, practice well.